Welcome back, everybody. I hope that worked out for you okay. We've all got a little bit refreshed. And I just ran up the stairs, so apologies. I'm a bit out of breath. That shows how unfit I am. But we'll now follow on with Violet Beattie and Elizabeth Ball. So as I said earlier, please don't take any conclusions from Violet or Elizabeth until they both conclude, because both their presentations work together and it's one big story. So with no further ado, I'd like to invite Violet now to present on her work, which is initially looking at driving down the crude protein of the diet and its effect on performance. So Violet, if you're ready, perhaps you can share your screen and come on that we can see you. Thank you.
I'm going to talk to you about the late finish period and moving pigs on into heavier weights and what nutritional requirements would be required from that. So the average carcass weight in Northern Ireland 10 years ago was somewhere around the mid 80 kilograms, but now we're up at 94 kilograms, which is equivalent to probably 122 to 125 kilograms live weight. And this is uncharted territory in terms of the nutritional requirements. Now, there's a lot of work published on the nutritional requirements of pigs at heavier weights, but predominantly this is coming from Europe, and this nutritional requirements are based on gilts and castrates. The big difference in the UK and Ireland is that we have entire meals or we have boars, and boars may have a different trajectory of growth to gilts or castrates. So what we did was we set up a piece of work. The first part was carried out here at Hillsborough, and there were 3 dietary regimes. So 13% crude protein, fed the whole way through from 60 kilograms to 140. So really talking about the late finishing phase for pigs here, starting at 60 kilograms, or we fed 15% crude protein the whole way through, one diet from 60 to 40, or we did what would be recommended in that we fed 15% crude protein from 60 to 100 kilograms, and then 13% crude protein from 100 to 140. And that's based on the idea that as pigs get heavier, that their potential to put down lean growth falls off. So therefore you shouldn't need the same level of diet in the later phase than in the earlier. In Hillsborough, they were separated by gender. So the boars were penned separately from the gilts, so we could see how both genders responded to different diets. As well as that, on a commercial farm, we replicated the trial. So again, 3 dietary regimes, 13% the whole way through, 15 the whole way through, or 15-13. But this time it was mixed groups of pigs. So the boars and gilts were held together in pens, the same as they would be commercially. On the diets, with the 13% crude protein diet and the 15, and Sam has alluded earlier that we actually tried to formulate this down to a 12% crude protein, but it analysed out of 13. And I think that's an important point. When we go through all this work, we're coming down to the levels now of the actual requirements of pigs, and we're coming down to very low levels of protein sources going into diets. So this is a whole new area in terms of formulation. It's a whole new area in terms of amino acid availability. And also when we get to these diets, we are reliant on methods of bringing amino acids in, not along with protein. And that becomes an issue when we get down into the lower amino acids, like arginine, isoleucine, etc. So let's look at the results. Well, it's interesting that in the early period, exactly what we thought might happen, the pigs required the 15% crude protein. This is up to 100 kilograms. Remember, 60 to 100, these blue bars, you can see the pigs perform better when they were on 15% crude protein compared to when they were on 13% crude protein. And that is exactly what you'd expect from the science. Now, in the later period, 100 to 140, it looks like the 13% crude protein diet is totally adequate, okay? And you can hear the 15 and the 13 do equally well. So what we could suggest then is 15% crude protein diet early on, 13 later on. But on the treatment where we did do that, The 15% crude protein responded very well from 60 to 100 kilograms, but the 13 did not perform well from 100 to 140. The interesting thing here is to compare that bar to here. So when the pigs were in 13 the whole way through, they grew totally perfectly on the 13% crude protein diet in the later phase. When we changed the diet, performance was hit quite dramatically when we changed from 15 to 13. Now, this is also reflected in the food conversion, and this is very important in terms of when we're going to look at nitrogen excretion. You can see here, again, the 15 did very, very well in terms of food conversion in the early period, better than the 13, suggesting the pigs need the 15% crude protein at that stage. The 13 did nearly as well as the 15 in the later phase. But again, when we changed the diet, the 13% crude protein really pushed the FCR out. Now, this is not surprising because there's plenty of literature suggesting this happened. And you can see here some work by Leake in University College Dublin back in 2003, where he had a 13-8 energy diet. So in terms of what we're saying here, the single diet here had the energy 13.8 and had a 1% lysine. And in the phase, he started again with 13.8 with 1.1, moved down to 1 and moved down to a 0.9. And you can see the FCR deteriorated just simply because of changing the diets. The same for McGowan and Ball. In 2012, the same thing happened. And there's also work by this group in 2015, another work by McGowan et al. In 2016, which also showed more variability within the pigs when we phase diets. So I think we have to be very careful in terms of how we think about changing diets on pigs when we hit the finishing phase. So if the finishing diet, if we move into a finishing house of 40 kilograms, and we're going on through to 130, we need to be very careful what we do in terms of diet change. Now, it's interesting if we look here at, just look at these as weight for age lines, and you can see that they're quite linear. And that might suggest why we're having a problem with phase feeding, because if pigs are being able to maintain a growth curve or a weight for age linear curve, then do we need to change diets? And that will be very much determined by the feed intake of the pigs. But the point of this graph is to show you Boars versus gilts. And you can see right back here at the start, at around 60 kilograms, Boars and gilts are starting to separate out. And that is what we'd expect. Boars have a higher lean deposition ability potential than gilts. And here we've got 180 grams a day protein deposition for the gilts or for the Boars, and we've 10 grams a day less at less than 170 for the gilts. So you can see what I'm going to suggest here is that possibly, especially when we go out to these later phases, we may have to feed our Boars and gilts separately. So let's just look at the data. Now, if we start, what I'm going to say first of all is let's ignore the phase treatment, because you can see here, if you look at the figures, that it really did hit the performance of the pigs. So it'll not be something we're going to look at in terms of the Boars and gilts, because I don't think it's going to be a factor in the way we're going to house and feed these animals. But if we look at the growth rate, you can see that 15% crude protein is the absolute optimum for our Boars. They're 100 grams a day better than being on 13, and again, the phase. So, 15% crude protein for Boars seems to be where we should be. And look at the food conversion, less than 2.2, an amazing food conversion. Remember, this is a period 60 to 137 kilograms. So that's an amazing food conversion on the 15% crude protein. Look at the gilts. You can see here on the 15% crude protein is actually the same as on the 13% crude protein. So in essence, what I'm saying here is that the gilts do absolutely fine on 13% crude protein. They have a poor food conversion, but that's simply because they're gilts. But the 13 seems to be adequate for gilts. It takes the 15 for Boars. And if we go down to what the important bit maybe in terms of this seminar, they're both going to be excreting then 36 grams of nitrogen per day. we kept the gilts on 15, we got the 42.5. So it seems like put the gilts on 13, put the Boars on 15 the whole way through. Let's look at that in terms of kilograms of nitrogen per pig. And you can see here that the Boars, it's very much similar, their excretion, no matter which diets they're on, slightly worse on the phase. So again, 15 seems perfect in terms of about just over 2 kilograms of nitrogen excreted per boar for that period. The gilt, you can see the 15 is going to lead to high excretion, and that was that over 40 grams a day, remember, excretion. So the 13 seems perfect here for the gilts, and we're slightly higher here at about 2.25 kilograms of nitrogen excreted per gilt over that period of late finishing. Now, let's look at the performance. Remember the commercial farm where it was mixed groups? And let's look at the performance there. And again, now this time, remember it's mixed groups. So this time the 15% crude protein diet seems to be optimum. But that probably is because 50% of these are gilts or boars, and they need that 15% diet. And they're being penalised when we go to a 13% diet. So it's coming through here, the 15, and it's following through in the FCR. Now, the important thing, looking at this on the commercial farm, we had 2 diets here. We had a 13% crude protein diet at about 238 a tonne pounds, and the 15 was 250 pounds a tonne. But you can see the cheaper diet gave us a return in terms of cost per kilo of 62 pence, and that's because it was a cheaper diet. And you can see on the 15% crude protein and the phase, it was 63 pence per kilo. But remember the difference in the growth rate. That means that we have far more carcass to sell. And so the return over feed per pig is about £2 difference between a 13% crude protein diet and a 15. And that, as Sam alluded to earlier, when we're looking at sustainability, we have to be careful because we have to look at sustainability too in terms of actual finance for pig producers. So that would be a huge cost for little environmental benefit to push pigs towards 13 compared to the 15. Now, let's look at the comparison of the Hillsborough excretion figures and the commercial farm. And you can see here that if we put these all together, Hillsborough's probably sitting somewhere around 2.1 kilograms of nitrogen excretion across the 3 diets per pig, so 2.1. And here in the commercial farm, it's about 0.2 kilograms higher in terms of nitrogen excretion at about 2.35. Now, we could argue that as a research farm versus commercial, but this group has done lots of work before comparing different farms. Way back, maybe 15 years ago, where we compared 8 farms, and we found over 250 grams a day difference in the growth rate of pigs during the finish phase. More recent work has shown food conversion differences of over 0.4 between farms. And I think this is an important fact to get across. How a farm performs will determine its nitrogen excretion. But also, when we go to formulate diets for individual farms, we need to consider the food intake and we need to consider the performance before we can formulate the diet. And that was the point earlier I was making when we were looking at the diet. If we're getting to this point where we're just meeting the requirements of pigs, we need to know an awful lot about the farm before we can decide what diet would optimally suit the farm, because it will be determined by how the pigs are performing on that farm. So to start summarising conclusions, there's no benefit of phase feeding environmentally or financially. It's going to cost roughly about £2 a pig to phase feed, and yet you can see here there's no benefit in terms of nitrogen excretion between phasing or on a 15, and yet it would cost financial money. So what we're saying is here, phase-wise is not an option at this period in terms of any benefit. Second conclusion I'd like to make is there's large gender differences in performance. Now, these are two pretty novel things I'd imagine for people to take in. We've been told repeatedly to phase feed, and as I say, that's been coming from European best available techniques, etc., because they're using gilts and castrates. Okay, so I'm saying here now, I'm saying we shouldn't phase feed, and now I'm saying is that we have to separate boars and gilts. And maybe the difference between boars and gilts is greater than the difference between gilts and castrates. And some work that was done here well over 20 years ago did suggest that entire meals are on a totally different trajectory than gilts or castrates. So split sex feeding, and what we're saying is if we split sex feed, 15% crude protein for boars, 13% crude protein for gilts. And if we look here, just the nitrogen excretion by boars and gilts, you can see really if we stay on the 15, it's not much difference than being on the 13. And for gilts, the 13 is where to go because the 15 is causing excretion. My last point is good performance equals less excretion. So what we need to do is to try and improve performance across all units as much as we can. And you can see here that if we look at the two farms we compared, Hillsborough versus the commercial farm, the difference in food conversion is reflected in the difference in nitrogen excretion, which is about 0.2 kilograms per pig difference between the commercial farm and Hillsborough here. So to conclude, I'm saying no phase feeding is no benefit. We need to split sex and feed accordingly. We need good performance, and we've got to be very careful with our formulation as we get to these very low protein diets. I would just like to thank DAERA for funding of this project, and along with contribution from Thompson's and Devenish. I'd like to thank Preferred Capital Management for the use of one of their farms, and I would personally like to thank Devenish staff for carrying out the commercial trial. It's a lot of bag carrying, and special thanks to Emma and Courtney and to the other staff at Devenish. Thank you.
Thank you very much, Violet. And I'm going to just maybe ask you to clarify, whenever you say phase feeding, are you talking about, 100 kilos or before that?
Well, that was from 60 kilograms, that work, Elizabeth. And some of the previous work has been going, I'll just stop sharing here. Some of the previous work has been earlier than that. Some of the work by Leek and some of the work by this group before. So I think it's important, and even some people know that from, when you move even from a grower to a finisher, I think work here has shown, that you do depress the intake for a while people are when the pigs are getting used to the change in diet.
Mm-hmm. Thank you, Violet, and just that helped us get over to Elizabeth Ball's presentation. So as I said earlier, don't make any major conclusions until we see through what Elizabeth Ball's going to tell us. There we go. Thank you. Over to you.
All right. Thank you very much, and thank you, Violet. I'm the second act on this process that we're taking you on today. My first paper took you back in the past, and what I want to do with this paper is take you a little bit into the future in our journey on reducing nitrogen excretion. And it's very much a follow-on from what Violet has presented. Our previous work demonstrated the importance of supplying the adequate lysine and indeed the other amino acids in a balance. And one of Violet's main conclusions was the need to separately feed our boars and gilts. So it was concluded that boars require 15% crude protein and gilts require 13% crude protein with balanced diets in terms of amino acids. But we're always looking to the future. We're always thinking, could we get a little bit more reductions in nitrogen excretion while still maintaining that performance? And is there a way that a 13% crude protein diet with a higher level of lysine and other amino acids, is there a way that could be adequate for both the gilts and the boars and achieve maintain performance and achieve reductions in nitrogen excretion. So to answer that question, we designed a trial with 6 treatments. Now my next slide will give you some more details on what this low lysine treatments are and the standard lysine treatments. But with 6 treatments, with 13% crude protein, with low lysine offered to boars and gilts separately, 13% crude protein with standard lysine offered to boars and gilts separately, and then the higher level of crude protein at 15% with a standard lysine and amino acids offered to boars and gilts separately. These treatments were offered to a total of 180 pigs that were housed in pens of 10. And in the pen, the feed was offered through our individual fire feeders. And that allowed us to get some very detailed information on individual pigs. We were able to record their individual feed intake at each visit and also their individual body weight at each visit. So we could look at daily feed intake, we could look at daily live weight gain on an individual pig basis. And the diets were offered from when the pen weight average was 65 kilograms to a pen weight average of 115 kilograms. So it was a one stage later finishing diet right through from 65 to slaughter. So I said I would discuss a little bit about what I mean by low and standard lysine. So in this table, you can see I presented the formulated crude protein and lysine levels and the analysed crude protein and lysine levels. And this has been discussed before by both Sam and by Violet. But just if we look first of all at the 15% crude protein, you can see there's a very good correlation between our formulated and our analysed values of 15%, and a very good correlation between the formulated and analysed lysine. And that enabled us to have achieved the target lysine to crude protein ratio of 0.075, which we had established in previous work was an optimum ratio to drive optimum performance in terms of lysine or amino acid ratio to total crude protein. Similarly, in the 13% crude protein, we achieved a very good correlation with analysed values of 13.2 and 0.97% lysine, and we achieved our target of 0.75 lysine to crude protein ratio. However, as we have highlighted before, when we formulated to 12, we achieved a 13.2% crude protein. But there was a good correlation in the lysine and the other amino acids in terms of the relationship between the formulated levels and the analysed levels, and that resulted then in a lower lysine and other amino acid ratio to the total dietary crude protein. So instead of a 0.075 ratio, we achieved a 0.067. So that is why we're terming this particular treatment as a low lysine or a low amino acid treatment in relation to the crude protein. Now, just for ease of discussion of this trial, I'm going to focus on it in 2 parts. So the first part I will discuss is the comparison between the 13% crude protein low lysine amino acid diet and the 13% crude protein standard lysine, and then we'll consider the 15 versus the 13% diets separately. So first of all, the low versus standard lysine and amino acid contents. Well, I'm not going to go into all the details in this table, but firstly, we've seen that boars outperform gilts, and that is in support of what Violet has just said a few moments ago. And what I want to really focus on in this table is the fact that boars are impacted by the low lysine content. So you can see here that if we consider average daily gain, you can see average daily gain is 1.18 kilograms per day. But when they were offered a higher lysine, a standard lysine content at the same crude protein level, average daily gain was 1.27 kilograms. We also observed a very significant reduction in feed efficiency. So the boars that were offered the 13% low lysine diet were much less efficient at converting feed to gain. So you can see there the feed conversion ratio is 2.37 versus 2.18 for the pigs receiving the low crude protein standard lysine diet. So this reduction in performance had implications for the nitrogen excretion, and it obviously reduced nitrogen retention, so 30.1 grams per day for the boars on the low lysine, compared with 32.6 grams per day for those on the standard lysine diet. And that then reflects on the total nitrogen excretion. And I think it can be best shown on the nitrogen excretion per kilogram per pig over the finishing period. So if we offer a low lysine diet, which results in poor performance, you can see that nitrogen excretion increased from 1.04 kilograms per day per pig up to 1.25 kilograms per pig. And this obviously will have quite significant implications for the environmental excretion of nitrogen. If we are offering boars diets that are not sufficient to maintain performance, we will see an increase in nitrogen excretion. And when we calculate that up to what it means for all the finishing boars in Northern Ireland, you can see a significant increase of over 290 tonnes per year increase in nitrogen excretion by offering that diet, which is not adequate to maintain performance. So then we are still asking ourselves the question, can we lower that crude protein in the boar diets to achieve a reduction in nitrogen excretion? And is there some way that we can supply that added requirement for amino acids? So we compared then the 13% crude protein diet with the standard level or the higher level of lysine and other amino acids with the performance of pigs offered a 15% crude protein diet. And you can see in this table that we didn't see any significant difference in the performance. There's no difference in pig days and our intake, average daily gain, our feed conversion ratio. So that because we were able to maintain the performance across both boars and gilts offered the 13% crude protein diet with the higher level of lysine, we were able to show a reduction in nitrogen excretion. And that is reflected well in the nitrogen excreted in kilograms per pig over that finishing period. You can see 1.18 kilograms versus 1.54 kilograms per pig. So a highly significant reduction by reducing the dietary crude protein and maintaining performance. If we don't maintain performance, we will get the reduction or the reduction in or the increase in nitrogen excretion. The point has been made that we need to consider economics and reducing the diet from a 15% to a 13% crude protein, even with unbalancing the lysine and amino acids to the same ratio, we can actually achieve a higher return over feed. And that's simply because the 13% crude protein is less expensive, and we were able to maintain performance in both boars and gilts. And for boars, it results in £2.50 more for boars and £2.89 per pig more for gilts by reducing the diet costs. So, have we got it? Are we able to implement this across Northern Ireland? And we have a very positive message here, but I think we need to consider something, a very important factor, which Violet has already alluded to, and I'm going to present some more information on it. And that very important factor that we need to keep in mind is the fact of on-farm variability. Now, as Violet said, we have shown this in previous studies over several years, and we're not alone in this. And in the literature, there's many studies which shows the variation between farms in pig production and pig performance. Now, I've put this table in to show you in this instance the difference in performance between AFBI and the commercial farm. We have other work where we could flip this around, and it is a commercial farm that is performing better than AFBI. But by way of illustration, I just want to make the point in this case that AFBI's pigs are performing better in terms of higher intake, higher growth, more efficient in terms of converting that feed to gain, and ultimately less nitrogen excreted in grams per day. If we had a blanket approach to offering the 13% crude protein diet, even with the higher level of lysine and at that optimum ratio of lysine and amino acids to crude protein, if we do not know the intake of a particular farm, we are in great danger of undersupplying the essential and indeed the non-essential amino acids, and particularly for boars. And then we will be in a scenario of actually increasing nitrogen excretion rather than decreasing nitrogen excretion. So that would be an area where we really need to focus in on how we can be more precise in understanding the performance on farm and then tailoring the nutrition to that farm, specifically to the requirements of the pigs. And then I just want to end some of this part of the trial with another important finding that has arisen from this work, and that is the fact that our nitrogen excretion values are lower than the values that are quoted in some of the current standards. Now, we all know that ammonia is one of the particular problems in Northern Ireland, and we're seeking to reduce ammonia emissions, and there is a large-scale program of research seeking to reduce ammonia emissions. But what we have seen here in this study, regardless of whether the pigs were offered 15 or 13%, when nitrogen excretion is calculated on a kilogram per pig placed per year, the values are coming out lower than what is quoted in the current standards. And there's a number of reasons for that. The nutrition of the pigs have changed since this value of 14.4 was determined. Crude protein levels have reduced, but there's also advances in genetics, there's advances in management, which has improved the performance of the pigs, thus reducing nitrogen excretion. Now, what I wouldn't want you to go away with is the figure that we are suggesting that the UK infantry should be updated with 11.2 or 8.6 kilograms per place per year. But what I do want you to take from this is that this is further evidence to contribute to our discussions to updating the UK ammonia infantry. This work and other work which we have done both within the consortium and outside the consortium will be feeding into our discussions to seek to update that infantry. So just to conclude, as I said, we are working in partnership with the livestock reduction project to assist in updating the infantry. We have seen in this study that boars perform better and they excrete less nitrogen, therefore providing more evidence that they should be housed separately or at least fed separately. They require a higher level of lysine, and if we don't give them that higher level of lysine and other amino acids, we will actually reduce the performance in the boars and increase nitrogen excretion by 17%. So that's not something that we want to do. Crude protein, if we have careful consideration of the lysine and amino acid balance, and if we are able to maintain performance, that would actually reduce overall nitrogen excretion by 23%. So it's worthwhile trying to get that extra reduction in the boars. It would also be worthwhile economically because it would result in a higher return for feed costs. But as I've highlighted, careful consideration is needed and careful precision is required so as that we can retain that performance on farm before we recommend that a across the board level of 13% crude protein is adopted in Northern Ireland, because if we see that drop in performance, nitrogen excretion will increase. So thank you all very much for your attention.
Thank you very much, Elizabeth. I'm going to start with a question from Paddy Savage. And Paddy, of course, no question is a bad question. And Paddy is very heavily involved in leading the ammonia inventory and the ammonia research programme for the DERA side. And we have a lot of policy colleagues on the line. So I think it's useful actually to clarify Paddy's question around, why do we in Northern Ireland have boars? Why do we not have castrated pigs? So maybe if we can just clear that up before we get into the other science around crude protein, might be useful for policy colleagues.
You might take that one on, Elizabeth.
Yes, please.
Okay. And that is under welfare regulations that we don't, castration is a surgical operation on young pigs. And they've been trying across Europe to use a chemical castration with limited success. So in terms of UK welfare legislation, we are entire meals. So it's very much a welfare thing. Plus, of course, it's very much advantageous in terms of production, because boars are so much better at putting down lean meat compared to castrates. I mean, castrates are probably, Kelvin will probably correct me in this, but probably 10 to 20% worse than even gilts. So yeah. Boars are the optimum in terms of production.
Sure. So question here from Mark Haw and John O'Doherty, similar vein. Any carcass quality information from these trials, percentage leanness as a result of the dietary treatments? Can you comment on carcass impact?
We haven't seen any difference in P2. We didn't do any more detailed carcass composition analysis on that, but in P2 we didn't see any significant effect. And on the AFBI pigs, Violet, I think you had maybe something more on the
commercial
kill out percentage.
That was on the odour trial. Actually, was on the kill out percentage. I'm trying to think actually on the.
We weren't seeing any significant impact on carcass quality in what we measured, but we didn't take it through to meat quality or anything like that. But certainly it didn't appear to be resulting in fat pigs, and any indication that we were wrong in terms of energy supply. So,
and that's likely the balancing of the amino acids in the background as well, is supplying the pigs with their amino acids, and not the whole crude protein. Charlotte here asks, complex problem. What do you think is the barriers at the minute to farmers being able to adopt this, and what would maybe encourage farmers to take up these findings?
Will I start, Elizabeth?
We never know who's going to answer.
Don't fight.
What I was going to say is that to be fair to farmers, this will be very new in terms of saying to them that phase probably is not the way forward, and that they would have to split sex their pigs. I mean, these are things farmers probably will not have heard, and we haven't heard it yet, because this is very much a policy related webinar. So it is feasible to sex pigs at weaning, and then to take them through like that. And larger producers can obviously just send boars to one finishing house and gilts to another. I think this is somewhere maybe policy can come in to help, is that for smaller producers who are going to have to put possibly gilts down one side of the house and boars down the other, they're going to need 2 overs and a finishing house and 2 bins. So, if there's some way of helping the funding of that to move forward in terms of environmental policy, I think that would be the big win.
Okay, thank you. I'll maybe invite Sam and Linda back on the line, and maybe Alistair as well, if you're still there, Alistair, and haven't got sucked into some emergency that sometimes creeps up on a Friday. I suppose another question here, specifically maybe for Violet and Sam, more so than anybody. The vibe I'm getting here is that the early work that Elizabeth presented was all about pushing down the corporate, if you like, crude protein level, and that could be applicable to Boars, gilts, regardless of performance on the farm, and was effective. We're getting now to a level of reduction that is requiring a lot of precision, and precision with regards to how we group the pigs, with depending on what your farm characteristics are, maybe your genetics of your farm, etc. So, and into the future, I suppose, what you're telling me is, today we could probably split the pigs, boars and gilts, and offer 2 diets, and that maybe would sort today. But actually going into the future, we're getting to a much more granular level of precision. Just wondering, what kind of challenges does that present to feed mills as much as anything as well? And because you could well have a bespoke diet for every farm in Northern Ireland and beyond. So, if you have any comments just from a feed mill perspective on how you as practitioners can support the industry actually into the future, and what maybe you're thinking of?
Yeah, well, maybe on the aspect of being bespoke, Elizabeth, I think it's unlikely, I think, to go to that level of fine detail. I think we can actually bring an awful lot more precision to what we're doing through the management side of things, like the ability, as Violet actually says, to feed a second diet to boars and gilts is a very immediate one, which really doesn't actually necessarily mean bespoke diets. We're into maybe a second diet and a second bin. So I think the potential for it to get overly complex isn't really there. I think we can gain quite a lot by a very small, potential change in how we feed the pigs. So I don't want the feed industry to be blamed for holding it back now in the feed mills, because I think it's in our interest to have a sustainable industry. It's in our interest to try and support what's actually happening in terms of the pig producers. So yeah, I think it's something that we'll deal with, but I can't see it going to the point of complexity where for feed mills say, no, this isn't going to work.
Sure. I would like to add on that.
Yeah, I think one of the major things, okay, we've said there about fees, we've said about gender. One of the major things that I think producers are going to look at is weight. Huge variations. So pigs, a man will say to me, I've moved my pigs in Devenish and I moved them with 40 kilograms or 45 kilograms. There could be a range there from 30 to 55. Doesn't matter about the heavier pigs. It matters very much so for those lighter pigs. Those lighter pigs, when they're at 30, cannot go into a diet that has been formulated for a 45, 50 kilogram pig. And I think the variability, and Elizabeth, we have done a lot of work in this consortium about variability, and we can't get to the answer of it. So I think precision on a farm is going to have to be about creating space to stream pigs in terms of weight. And I don't know how that's going to, that's very, very difficult. And I think that is, but ultimately, if environmentally we're being, we have to get very precise in what's excreted, I think that's going to have to be something that's looked at in the future.
Okay, thank you. I'm just going to go back on a question that Zanita asked you, Sam, and you did respond, but maybe just for the rest of the audience, if that's okay. And maybe Elizabeth and Violet might have some comments around this, or even hypothetical answer. With regards to the impact on the dry matter of the slurry that you presented in your work, in your presentation, Sam, can we hypothesize, or do we have any evidence around the nutritional value of that slurry, and if it was just simply more concentrated, or and what the potential implications of that could be going forward? Would you like to comment?
Yeah, I can't actually recall. I think there was some maybe low-level analysis done for the digestibility studies. The outcome of those I can't remember, but certainly I don't think it was down into the level of the likes of phosphorus on specific nutrients like that. I would expect the nitrogen aspect to follow the intake. and in line with some of the papers actually that Elizabeth invited, has shown that we should see that reduction in nitrogen excretion through the slurry. The rest of the nutrients like phosphorus, I think it's very possible that all we could be seeing is a concentration effect. There was no reason why the phosphorus, for example, should be any lower, where we weren't actually particularly doing anything with phosphorus. If we had FCR benefits, obviously that performance effect has a positive impact on phosphorus excretion. And again, back to the point that Violet made a number of times, that we want efficient pigs for an environmental point of view, not just an economic point of view. But the phosphorus level potentially could be slightly more concentrated just because of the lower amounts of moisture actually in the slurry. But I can't remember just any of the finer detail, Elizabeth. Elizabeth Wall might have some of the figures there.
The slurry wasn't analysed for phosphorus. No, it wasn't. For digestibility, we investigated dry matter digestibility, nitrogen and energy, and I think it was oil digestibility as well. So there was no analysis done on phosphorus. But I agree. I don't think there would be any effect on the phosphorus apart from the concentration effect of the higher dry matter on that and the other minerals. It's something we still have. We still have the samples in storage, and it's something that we maybe will do just to verify that and to confirm our expectation that there wouldn't be an effect apart from the concentration, and maybe put some figures to that.
Okay, and reducing the dry matter of pig slurry is always a benefit whenever it comes to the future separation or centrifugation of the pig slurry for onward transmission. So it would be interesting just to understand just how much less separation it could then take if that was the case going forward. Hugh McReynolds has asked a question here with regards to, he's working very much the coalface with farmers. And he's just wondering, how do we take this, how do we communicate this great work widely, and how do we help the industry as a whole utilise these findings?
Okay, well, I'll start off, and then Violet and Sam can pitch in. From an AFBI point of view, I think this seminar has kicked that off, our process of dissemination of these results. And we will be working closely with our CAFRI colleagues in disseminating this out further in farmers groups, etc. And also there will be technology transfer articles and other events where we will be talking through these results and with groups. And then, of course, there will be the...
Oh, we've lost your volume. Okay. Say that again.
Was I on mute that entire time?
No, you weren't. We just lost your volume for some reason.
Oh, okay, right.
Say that wee bit again.
I can't remember what I was saying, but I think we'll engage with our farmers groups and with CAFRI, and also with the our policy. We'll continue engagement there to ensure from an AFBI and a group perspective that we keep getting this results out, because we don't do research to lock it in the cupboard. We do it to have an impact to our stakeholders.
Yeah, I think also it was either Elizabeth or Alistair mentioned at the very start, as one of the benefits of the way the consortium has been set up with the commercial partners, Thompson and Devenish, we're in a very strong position actually to take that science and get it actually practically applied very fast. And I think all the data that we gain out of the research group obviously is implemented in commercial diets, with a lot of confidence. So, in terms of the communication, there's probably a fair point to say that maybe a lot of the farmers actually maybe don't actually appreciate and realize, what sort of position they're in and what they're already doing to contribute. They're already using the diets and maybe reaping the benefits, but maybe not actually totally aware of the actual figures that are supporting it.
Okay, folks, I'm just any unintended consequences from all of this. We're putting out, and it's a great positive message that you have there around being able to reduce protein, balance with amino acids, to reduce ammonia emissions, perhaps even an effect on odour, which needs further investigation. But have you any concerns around any unintended consequences that you maybe are starting to think about and trying to, what are your next big questions that you need to now start to answer? Oh, I've stumped you now, sorry.
Sorry, go ahead, Violet. Go ahead.
What I was going to say is I think these are not going to be easy things to implement. And, as Sam said, yes, we're on the ground. But I would hate to say we put something out and producers just went out the next day and said, oh, I can take my diet to 13% crude protein.
Yeah. And
I'll feed a 30-kilogram pig at 10 weeks of age. And it would just be a total disaster. So it's about it's not a simple message. It's one that I think we have to walk hand in hand alongside farmers to implement. But yes, it's a positive story. It just has to be done right. I think that'll be important. But Northern Ireland's small. The pig industry's small in terms of the number of producers you have to get around. So. And another point, just back to Hugh's question and part of what Elizabeth said, this work has been done under scientific rigour and will be published. So therefore, hopefully we can use the published papers to influence policy in Northern Ireland, policy in the UK, and even take it further. Because once it's a published paper, it should hold under the rigour of scrutiny in terms of legislation. Mm-hmm. Sorry, Elizabeth.
Yes, I was really going to say what you were going to say. My fear in putting out a message that it's taken up too simply and, let's go to the 13% crude protein across the board, and those early pigs will suffer as well as the boars in the later stage. But one of the studies that I presented in the first paper showed that, that early finishing stage from 30 kilos up to 45, the pigs cannot cope with the lower crude protein, lower lysine level, and they will melt in production performance and ultimately have dire consequences for economics and environment. So that would be, you asked about what our concerns would be with the message. It's not a concern with the message because our message is not that simple. Our message is saying, let's really be precise, let's understand what we're doing. But we need to get that hand-in-hand message that it's not just a simple message. It's something that you need to do in combination with knowing your performance on farm.
So, Alistair, you've dedicated a lot of time to us this morning. Thank you very much for taking your time out of your busy schedule, I know, and in reward for you staying online. I was just wondering if you would want to comment on, what you've heard and how it actually helps the policy environment and DAERA to take through and realise the impact of the policies that you're designing at the minute.
Sure. I think, first of all, it was back to my initial comments around the work of the group and just the reassurance that we get from the robustness of the data and the scrutiny of the data that's produced. The ammonia is a very significant challenge to agriculture in Northern Ireland. As a reduction measure, being more precise over protein, where it can be, is one of the measures that has a very significant impact. And that's come through the seminar today. So I think one of the messages that clearly comes out from the data is a very significant impact that precision feeding can have on nitrogen excretion. And also that where it is applied correctly and with the appropriate precision, the financial data looked favourable as well. So it is one of the reduction measures which have applied effectively and with the correct advice and linkage between the scientists, between advisors, between industry practitioners can come through and have a real impact on nitrogen excretion and hence ammonia emissions from Northern Ireland. So I'm very reassured by the breadth of data, the focus that's been given in this area. It aligns with the modelling work that we did on ammonia emissions, bringing that impact of reducing protein through to atmospheric ammonia concentrations. So yeah, it's been very valuable to listen and hear the presentations today, and just stress the importance of the work. And I get very much the message and the caveats that Elizabeth and Violet are highlighting in terms of application through it. But I think there are strong foundations here to take this forward in Northern Ireland in a way that's going to deliver and be effective, both from in terms of the economic performance of the industry, but the environmental performance of the industry as well.
Thank you, Alistair. And if I could maybe ask Sharon to start sharing some slides. Elizabeth, Violet, Sam, and Linda were all very brave sharing their own slides. I'm not just as brave. And I'd just like to take these last couple of minutes to give you some of the key take-home messages from today. What we now know from today's webinar is that diet can affect the prevalence of some offensive odour compounds, but there is a lot more investigations are required here. And as Linda said in response to one of the questions, it's a multifactorial problem and will require multifactorial solution. Diet could be one of those, but there's a lot more work needed in that space. What we did do and what we did here was the assurance around the fact that for each 1% reduction in crude protein off the diet, we do and can see a 10% reduction in ammonia emissions. So literature has been suggesting this, and for the first time in Northern Ireland, using Northern Ireland diets, Northern Ireland pigs, we have been able to ground truth that finding of 1% reduction in crude protein equates to 10% reduction in ammonia emissions. As well as that, Elizabeth Ball highlighted that we now have new data available on the nitrogen excretion from pigs at these various lower crude protein levels. And we do need to feed that now into the discussions on the UK ammonia inventory and other data platforms that are informing our policy and targets going forward. So things that we could do here and now out of this research. We can reduce crude protein even lower, and that will lower nitrogen excretion. But the big caveat here is that needs to be balanced appropriately with amino acids to ensure the optimal performance of all pigs, both boars and gilts. The work has very strongly suggested that boars and gilts should be fed separately and therefore housed separately. And boars will perform optimally with a 15% crude protein, with of course balanced amino acids, and gilts 13% crude protein diet, again with balanced amino acids, and that's from about 60 kilos to slaughter. Now looking to the future, there is further gain to be made, and that potentially is around boars being offered a 13% crude protein with balanced amino acids. But I think what's coming through here is a higher degree of precision will be needed on farms and potentially tailored to farms to ensure that performance remains optimum, because otherwise nitrogen excretion will go up and ammonia emissions will go up. But that is potentially the future. If that was possible, nitrogen excretion could be reduced by a further 190 tonnes per year, which is equivalent to 6% reduction of nitrogen from late finishing pigs, i.e. from 60 kilos to slaughter. And what we've also heard here this morning is the fact that diets really should not be changed, especially during that late finishing period, for example, 100 kilograms upwards, and phase feeding needs to be taken with major caution, as this has the potential to reduce performance, in fact. So folks, thank you very much for your attention. It's been great to have you virtually online. Unfortunately, we can't see everybody, but I know you're out there, and I hope you have enjoyed the findings from today. There is a booklet, and you should have it by now. If you don't, please do get in touch and we will share that with you. It'll be available on the website going forward anyway. But for now, thank you very much for your attention and hope you have a great day.